It is now. All right, so you can see, I don't know if you're able to read that, but you should be able to see the numbers underneath there. They kind of got washed out, but this is 11, this is 106, and this is 30. So we're gonna add some salicylic, some iron chloride to each one of those to see if it turns purple. So I'm gonna add it first to the crude because I want to see what happens with the crude. And I only need a couple drops. See that? So that first sample is crude aspirin. That's the aspirin before we purify. You see how purple it is? That's full of crap. That's what you don't want. So now we know what we don't want to see. So I'm going to add this same iron chloride. I'm going to add a drop to pure salicylic acid to see what happens there. Hopefully you can still see that. So we're going to add 1 drop, 1 or 2 drops to just pure salicylic acid. You can see right away how dark it is. All right, and that's what you expect. Because in the video, it said that the iron chloride forms like a complex with salicylic acid and it turns purple. So you can see that. Can y'all see that? So the plain pure salicylic acid also turned deep purple. What you don't want is for your aspirin sample to look that color. You want it to be lighter than that. The lighter it is, the less salicylic acid is left over after you purified it. So let's see what the first, this is sample 11 out of drawer 11. So this is gonna be your sample. Let's see what happens. Come on, Jesus. That's great. See that? You can go and check it out. Y'all can lean in, just hold your breath. I'm joking. I'm joking. You can see immediately that first sample 11 on the end, can y'all see that? Right? It didn't turn purple at all. It turned like a very faint purple, which is good. That means it's very pure. If it was dark purple like the other two, that would be bad. That would mean that it's crappy and you have to purify it again. All right, I'm gonna do 30, which is here. 30 got a little more purple in it. Can y'all see that? You see 30 on the left, second row on the left, compared to the last well at the top right. 30 is a little bit darker than 11. So that means that it's a little bit less pure, but it's still not bad because it's faint. The purple is still faint. So that's good. All right. And if you want to snap a picture of this, you can for posterity. You can show your kids. 106. We got a problem with 106. It's 106 with no part. That's bad. Well, it ain't horrible, but it's darker than the other ones. Can y'all see that? See the difference? How 11 is like really like faint, and then 30 is a little darker, and then 106 is very dark compared to both of those. Can y'all see that? So this is 106 here, and this is 30, and this is 11. You can see 11 out of those 3 samples. 11 is the purest out of all of them. All right. Any questions about the purple color test part?
Yeah, I have a question. So when we're filling it out in our chart, with this is the chloride test, correct?
Yes. So pick one. You could pick 11, 30, or 106 as your sample. Okay. And whichever one you pick, just keep that, because I'm going to send out the masses because I already weighed out everything. So you'll know how much actual yield you got, so you can calculate the percent. Because the theoretical you should already have calculated.
Okay, thank you.
All right.
So
all right.
Color, it says color of crude aspirin on there twice for the period.
Yep. So on the second place where it says it, line through that and put salicylic acid, because that's what we measured. That's the very dark spot, the dark purple on the second row at the top. I mean, the second well at the top. That's plain salicylic acid by itself.
Okay, thank you.
Hopefully everybody else got that, where it says crude twice, line through one of them and put salicylic acid. All right. Any other questions? I need a cameraman. I'm gonna have to hire me a TA for this. This ain't working. All right. Let me see if I can pan that. Yeah, you can still see it from there. All right. So I need y'all to do the same thing. Take a little small sample of your aspirin, and we're gonna do the pH test over here. And this time I won't drop the ethanol because I'll have both hands. If you watch that pH a bit, yeah, sure. You're in 11, right? Right there. Put it right at the top left. If you watch that video about the pH and the purity, there's a color coded there's a little color coded card where you can look at and kind of use that to determine the pH. So since y'all here, yeah, there you go. You're 106. Since y'all here in person, you can see it. But this is the code, the color code for the pH. All right, so we're gonna use that. We're gonna dissolve these samples up in ethanol, just like we did the last ones, and then we're gonna use this guide to kind of help us determine what the pH is. If it's the darker red it is, the more acidic. As it turns from red to green, neutral, and green to blue is basic. But you don't expect it to be basic, right? Because there's a free carboxylic acid in that aspirin molecule. So you expect it to be somewhat acidic. So let's find out. And pray, y'all pray hard that I don't drop this ethanol. Yeah, that's still clean. All right, so I'm just gonna do the same thing I did last time without spillage. Dissolve these up in ethanol. And again, I got sample 11, sample 30, and sample 106. All right, so I'm gonna let each one of you do your own pH. And after this, we're gonna do the melting point, and that's really gonna be it. So, let's see, this one's already open. So we're just gonna take a small strip of pH paper, just like that, and they're just gonna dip it into where their sample is and read it. And you wanna read it immediately. You don't want it to sit because this paper is air sensitive, water sensitive. So it might start out red. You come back in 10 minutes, it's blue. So you want to read it right away. There you go. And then just record on your paper what your pH is, and then whatever you got for 11, that's what we're gonna put in the chat. What you get for 30, we'll put that in the chat. For 106, we'll put that in the chat. Y'all, we can work with off those values.
So did the whole thing in
Just the tip, just the edge of it.
orange?
Didn't change much, did it? So where are we? So it's orange. It's kind of right there about 4. Let me see. Let me show them so they'll know. So this is the pH meter or the pH guide, and this is the strip after she dipped it. So it looks like it's close to about 4, which is expected. Somewhere between 3 and 4. You expect that. Because again, on aspirin, you got this free carboxylic acid that is acidic. I mean, those proton is transferable. So go ahead, Brooke. About the same, huh? About 3 or 4. Same for that one. And again, this is the guide right here, so we can match it up. And let's see. Yeah, about the same. So we're looking at each one of the samples having a pH ranging from 3 to 4. So it doesn't matter which one you pick, 30, 11, 106, doesn't matter. They all have a pH of about 3 to 4. So we're done with that part. Now we need to do the melting point. And what we're gonna do the melting point with is this instrument right here. It's called a melt temp, right? And so the way we use the melt temp is very simple. First, we gotta plug it up. obviously, because it's electric. And then after that, what we want to do, the way you measure the melting point, if you watch that melting point video, hopefully you did, you ramp the temperature up. You know, watch. I seen your eyes. I seen your eyes. Don't think I don't pay attention now. You ain't watch nothing. You like, what video? All them links in that email. You know how much time it take me to put an announcement together? I mean, I'm sitting there just trying to make sure nothing is ambiguous. And here you go. What video? Don't do me like that. Come on. I work hard for y'all.
I know. Sorry.
I'm gonna edit that out and record it too. I'm not gonna blast you out on YouTube. But anyway, what you want to do is you ramp the temperature up until you get about 20 degrees away from your melting point. Who looked up the melting point for aspirin?
I did.
Oh, redeemed yourself. What is it? What are you expecting?
275.
That's
Fahrenheit.
Fahrenheit. So
Right.
about 135 Celsius, right? Okay, so we're expecting 135. So we're gonna ramp up the melt temp using this little dial right here. It's very rudimentary. We're gonna turn that dial to about 4, somewhere about 4 or 5. Don't do it yet because you don't have your sample in there. And then when the temperature gets to about 115, we're gonna turn it down to about 3.5. And that way it'll slow down the temperature increase. Because once you get to about 20 degrees out, you want to increase the temperature about 2 degrees per minute. This is very tedious and time consuming. That's why I save it for the last lab. Hopefully the NMR will be fixed next week so we can take NMRs of these samples too. But I'll probably just come in and just stream that out because that's a little small room and COVID. So we got 3 melting point capillaries and we're gonna put some sample into these. I'm gonna take one of them and put some crude in it for each one of you. So you're gonna measure your pure stuff against the crude. You expect the crude, you see that the crude, how dark purple it turns crap. So it's not gonna melt at 135. It should melt way before that because it's full of crap. The more pure it is, the closer it's gonna be to that 135 expected temperature that you looked up. All right, so we're gonna take some sample and I'm gonna show you this. Normally, you have a tube that you can drop your melting point capillary down in to get the aspirin to settle. What you don't want to do is jam it into the aspirin because if it gets stuffed, it's not going to go down. So let me show you what to do first and then you can take it from there. So I have, like a cooking show, right? I have some crude aspirin here, previously prepared by my producer. So I'm going to take the crude and I'm going to move this back here. Man, this thing needs to turn down more. All right, so that's my crude aspirin. I'm going to take my capillary. I didn't Apple put the camera in the middle. Take the capillary and I'm just going to dip it in here on the open end now, not the closed end. I'm just going to dip it in and you can see I got aspirin in the tip. Can y'all see that at home for your viewing pleasure?
Yeah.
Yeah.
All right. I'm just going to take this. Now, this is the part of the lab where you got to have some finesse, right? You don't want to just be slamming this thing down because these things are so thin. That's why they call them capillaries because they're thin. But you want to just tap it on the bench top, just like that. And you just keep tapping it until you can see a little bit of the aspirin has gone down, but not all of it. So you just keep tapping until you get it to the bottom. You want to have it about 1 centimeter, maybe a 0.5 centimeter from the bottom. That way, when you put it into the melt temp, you can actually see it. That's the purpose for the amount, right? Because that you already looked at that viewfinder, right? Yeah, it's like you need glasses and a magnifying glass and a microscope to actually see it, right? So y'all see how that got to the bottom just by a little finesse and a little tapping. So that's what we're gonna do. So I'm gonna put a little bit more in here because that's not quite enough. And again, you don't want to jam it because if you do, then it's going to get stuck at the top and it won't move. And you just tap it until it goes down. So y'all can see that now it's at the bottom. And this is what you're going to see inside the melt temp. So you lucked out because I did your crude for you. Even though you didn't watch the video. So you want to take some of that crude take your capillary, dip it in, and follow the lead. Just tap it. Just go ahead. Yeah.
So then where do you insert this?
I'm gonna show you. So go ahead and do your pure though. So wait, you gonna mix them up. You don't know what's what. That's crude over there. Make sure you keep them separate so you'll know what's what when you put it inside the melt temp. Yeah, that's good to start and just tap it. So what she's doing over here, you got finesse. I like it. I see finesse. That's what I'm talking about. So what she's doing here is her pure sample. This is the pure aspirin right here after we filtered it. And it's kind of good. We waited an extra week because it gave it time to dry because this filter paper is thick. It's like Bisquick thick. Horrible. Yes. All right. So just tap it on the bench top. You can, and when it goes down to the bottom, if you got about a 0.5 centimeter, you good. All right. Any questions from anybody that's streaming?
I have a question.
Go ahead.
It says within limits under purity testing. What does that mean? What do we put?
So-
it says yes or no.
Yes, so the industry standard for aspirin purity is no more than I think it's 0.015% salicylic acid left over in an aspirin sample. All right, so what we just did was we kind of tested it, and this was really a rough test. It wasn't super accurate, but I just wanted you to be able to see whether or not it changed colors. But the industry standard is like 0.015% leftover salicylic acid in any batch of aspirin.
So
Yeah.
it's no.
Yeah, so it does meet. We'll say 11. If you picked 11, it met industry standards because it barely turned. But if you look at 30 and 106, it turned purple. In 11, you can see more of the color of the iron chloride than you can see purple. You see how it's kind of brownish looking? Yeah. So that one, we could say that 11, one sample met industry standards, but the other two did. Is it still? Oh,
Okay.
that's
Thank
good.
you.
So that's pure one. Put that over. And then do another one. So we're gonna put three capillaries into the melt temp. It can hold up to 3 capillaries. So we're gonna put 3, and I don't know if I'll get close enough to show you the inside of it. Let me see if I can. So can y'all see that there's a light on in there? I'm trying to get the camera as close as possible. And there's that little circle. Come on, Russell. That little circle can y'all see that? Inside of that,
Yeah.
just like you see those little grooves in there? That's where your sample, it fits between those grooves in the melt temp. So you kind of ramp the temperature up and you look through that viewfinder to see if your sample is melted. It's very important when you're doing a melting point to write down the initial temperature when your sample starts to melt, right? So if this starts melting at 120 and it stops at 128, that's what you record as your melting point, right? Because it's really a range and not really a point. So there's a range of temperatures that your aspirin is going to melt over and not just a single point. All right, everybody got samples ready to go? Is yours stuck?
No, it's just taking me a long time.
Take your time. We got all day till 5. All right. Any other questions from anyone on Zoom while we are preparing our samples? Hopefully I'll be able to show you when the samples are in there so you can actually see it. This camera is actually better than I thought. So
I have a question in regards to the percent yield. Do you ever provide us with the actual yield? Like where
yes. Yes.
Oh.
The actual you're gonna get today.
Oh, okay.
I weighed if you recall the last time we had lab, we weighed the filter papers first, and then we filtered everything so we could subtract those masses out. I think I put it all in an announcement. But we'll go back and I'm gonna take that information and what we have today and put it in another announcement so you can get all the data.
Do I need these?
Look in there. Well, you kind of do. I don't have mine, so I ain't gonna be a hypocrite. I ain't saying what I don't have because it's going on YouTube, but yeah, you good. He's trying to make up for not watching the video and take a slip. Crew, all right, so this is gonna be your crew. We're gonna let me show you how to load this thing up. So if you look up top, come and look over top of that. You see those three little squares that look like that, you can take. Like three,
Yeah, I see 'em.
three little squares. So you're gonna put this down into the first. Come on. If you look through there, you'll be able to see it. Yeah, you can take them off. Can you see it? Yeah, so let me see if I can get a view for our viewing audience. All right, so here, come on, Russell. I don't know if y'all can see that sample in there, but we have one sample loaded. Trying to get it, there we go. Can y'all see that sample, that tube that's in there? Can you lift up on it a little bit just to see if we can see it, if I can see it moving in the camera? Yeah, there you go. Can y'all see that?
Yeah.
Okay, that's one sample. So we're gonna load the other two samples in. And then we're gonna ramp that temperature up. And when it starts melting, we're gonna ramp the temperature down and slow the heating down so we can get a good, accurate melting point. You ready? Yeah. All right, so look over the top of your, right here. So yours is open, you got an old school joint. So that's, what is that, pure? Yeah. So put that where you want it. You got crew already? That's crew, so put that one on the end down. It's 3 slots. Can you see it through there? And then put your 2 pures next to it. There you go. I don't believe I made such a huge mess. I had this so neat when y'all came in here. We good now? Or you
I got one more.
one more?
This stuff is thick. I gotta fix it up.
All right, we good. You can go ahead and you got all 3 of your samples loaded.
Yes.
So turn your dial. Now you gotta watch this thing because I'm telling you, I've had students turn it up and then they start talking and then look back and it's already melted. So you don't want that to happen. You don't want to miss that initial temperature. That's why, then I have 2 temperatures on there, the melting point. Or do I even have the melting point?
I don't think you do. Or is there another sheet or is this?
That's the same one. I'm gonna have to,
Yeah, I just write
I'm gonna edit it. I'm gonna have to edit it. That's all right.
So you have to
turn-
crank it up to 4,
Yeah, 5.
5.
And then when it gets to about 110, turn it down to about 3.5.
Is this in Kelvin?
This is Celsius. You must be, you British or something? You mean Fahrenheit, Kelvin? We in Celsius. You good? Go ahead and crank it up. And to 5? Yes, put it on 5. And then when you see that thermometer get up to about 110. Right there, you see it get about 110, turn it down to 3. And you don't have to watch it the whole time. You really want to be watching the thermometer. Right? When it gets to about 110, that's when you're going to make the adjustment on the dial.
To 3?
Yes, 3.5. Right? That's the thing about the melt temp. If you just put it on 3, we'll be here till tomorrow. So you ramp it and then you slow it down so you can get a good accurate reading. What's that? Let me see.
It's kind of small, but
Oh, you need a little bit more, a little bit more. I wish I had like one of those fiber optic joints I can put down in there. Oh well. All right. So this is like watching paint dry. But I'm gonna try to get another shot of all 3. If y'all can see that, she has all 3 of her samples loaded in there. We're just waiting on them to melt. When they melt, I'm gonna take another shot of that, so you'll be able to see it. But when it starts melting, you're gonna see it's gonna be a little bit liquidy, but then there'll still be some solid. So when it first starts to melt, you write that temperature down.
Mhm.
And then when it's done melting, you write that temperature down. Right? And you gotta make sure you know which one is crude and which one is pure. If you don't, it's kind of defeating the whole purpose.
Okay.
You ready to go?
Yeah.
All right. Can you see your slots where to put your samples?
Oh, very.
Which one is, where's your crude?
It's that one.
This. All right, so we'll put that right here in the front, first slot. And then your two pure samples we'll put in the last two slots. Mhm. You should be able to see it through there.
Mhm.
There you go. Look, if you look through that little viewfinder, you'll see all three. And then just turn it up to 5 and watch that temperature. I promise you, if you blink, you'll miss it. It's gonna, because those things heat up fast. Clean up my mess. All right, anybody else have any questions about anything?
No.
I had this thing set up for 5 folks. All right. So again, when I send out the information, whichever sample you use to get your color, whether it was 30, 106, or 11, you're gonna keep that same number when you get your masses for your actual yield and all that, and your melting point. So you're doing a melting point for 30. Yeah. 30, you're 11, you're 30, and you're 106. Yeah, so we got to keep that together.
It's probably 100. It's not.
Well, that crude is probably gonna melt first, but if it's at 100, just got a few more. About what would that be? Minus 263 Kelvin. I'm just asking a question. Yeah, we all need a little bit more.
Okay.
You see the crude starting to melt?
It's starting to melt.
Crappy, ain't it? What temperature?
At
That's 110.
110.
Write that down for the crude.
So then I need to crank it down to 3.5 now.
No.
Oh, wait till the other one's done.
Your pure stuff hasn't started melting yet. That's just the crude that's melting,
Oh, not too fast.
and we don't care about that. What was the last temperature? Is it all the way liquid?
Yes.
What is it on?
It's at 115.
Now you can turn it down, because now you want you don't want to ramp all the way through your pure sample. So the crude melted already.
Yes.
Let me take that one out. Is it this one right here? The first one? I'm gonna take it out so I can show you. So you can see right here, that was a solid, and now it's kind of, let me see. And now it's fully liquefied, so that's what you're looking for through that viewfinder. And the crude for 11 was started at 110 and ended at 115. So that's about 20 degrees off the expected melting point for aspirin.
Okay, my second sample is melting now.
What's the temperature? 130, 125?
120, no, 128.
Okay, that's good.
Mhm.
Write that down. It started melting at 128. So sample 2, 128. Keep watching it. Because you're gonna miss it because once it starts, it's usually pretty fast.
My crude is starting to melt.
Okay, what's the temperature? Should be 100 and something. Oh, 120. Yeah, you already turned it down. Turn it down. Oh, about 3. All right. So you said 120, so write that down and then write down the temperature when it's fully liquefied. All right, I wanna, when both of yours are done, don't take them out, because I wanna try to get the camera to be able to see that.
This one is fine
125 is the final temperature,
for,
the crude,
yeah, for the melted.
all right. Have either one of your samples started to melt yet?
No,
Okay, good. It's coming. Put your melt temp on about 3.5, and the temperature should continue to go up.
All three of them are melted.
Everything is melted. How,
Mine is 70.
what's your crude?
Yeah.
What's the
It
temperature?
was 98.
Not, oh, that was 30. But see, we could tell because over here, 30 was kind of crappy when we did the iron test. So it started melting at 98 degrees. That's almost 30 degrees. Actually, that's 45 degrees off the expected melting point. All right, or 35 degrees, sorry. Let me see if I can get it here.
started to melt.
Huh?
One sample was started.
Okay, right, get the temperature. Let me see if I can let y'all see this. I don't know if I'll be able to see that, but everything in there should be, come on, camera, liquefied. Can y'all see that? I need a steady
A
camera.
little bit.
Yeah, a little.
Yeah.
Can
That's
someone
a-
type in the chat real quick what the original temperature and melting temp was for 11
Yeah.
and 30?
Yes, I'm gonna put everything in the chat once they record everything.
Do I need to crank it down there?
Mm-hmm,
To what is it?
3.5.
Can I keep mine on or turn it?
You can turn it on. Take your samples out and put those capillaries in that glass waste box. Good to go.
I think both of my samples are starting to melt.
All right, what's the temperature?
128.
Good, that's good. The closer you get to the melting point of actual aspirin that you buy at the store, the better. What you working with over here? Your stuff, is it melted yet?
No, it's still in the same state.
Okay. Turn your melt temp to about 4 instead of 3.5. Because it may not be. All right. So what did you get for your temperatures?
For the crude,
Mhm.
it started at 110 and the final was 125.
Okay.
For sample 1, it started at 128, the final was 135.
Oh, that's awesome.
And sample 3 started at 134 and the final was 136.
Awesome. That's good stuff. Let me put that in the chat. That was sample 11, right?
Mhm.
All right. So bear with my camera. Actually, I'm gonna turn the camera off so I can see my ugly picture. Chat. So sample 11. Come on, Russell. Crude was, tell me that again.
110 to 125.
All right. That's a large, if that melting range is that wide, that's bad.
Mhm.
125 Celsius. And then give me the pure.
Sample 1 was 128 to 135.
Okay, 128 to 135.
And then 134 to 136.
Pure 2. You said 134 to 136.
Mhm.
All right. So that's sample 11, and then sample 30. We'll get that when it's done.
It's
We'll
done.
get. Oh, it's done?
Yeah, mine's on.
Okay. What's your final temperature? Did you get the beginning and the final for both?
Yeah,
All right.
for the crude, it was 120, ended at 125. The first sample was 130, ended at 135, and then the second sample was 132 to 136.
All right, hold up. 130, 135, 130, so 132, 136. That's good. That means we made some good aspirin. Almost consumable, but not quite. 120. P1. I'm just gonna abbreviate pure 1 and then pure 2. P2. And what sample is that? 106, right?
Yeah.
106. All right, and then go ahead, Brooke. You
Um,
had 30, right?
yes. For the crude, it started at 98 and ended at 119.
Well, that's crappy.
For the pure, they both started melting at 128, and sample 1 stopped at 136, and sample 2 stopped at 134.
Oh, that's good stuff. 134. Good stuff. Let's see. All right, that's it. We can clean up and go. For those of you who are watching, I'm going to I'll send it because I just emailed that data to myself. I'm gonna send out in the form of an announcement what I just typed in with the temperatures for each sample, and I'm also gonna send the mass of that filter paper for each one of those, so you can subtract that out from the mass I gave you the last time. I'll find that data so you don't have to dig for it. So you'll be able to subtract out the filter paper and then determine the actual yield, so you can determine your percent yield. Because I think last time I sent out a message with the 4 grams as what we were starting from as a theoretical. So I'll go back and repost that. All right. Anybody have any questions about anything?
Dr. Russell,
Go ahead.
can I see the color things again? Because I had a class that overlapped, so I got in here late.
Ooh.
Is it gone?
I cleaned them out already.
Oh,
No, it's okay. It's recorded.
okay.
So all you gotta do, when I post the recording to YouTube and if you subscribe to the channel, you'll get a notification. When I post it, all you gotta do is watch the first part of the video because we did that first.
Okay, gotcha.
Yep, no problem. All right, any other questions? Thank God for cloud recording, I'm telling you. All right, if not, we're gonna go ahead and log out and we'll be cleaning up while y'all are doing what you're doing. And then next week, I think if the air compressor is fixed on the NMR, we're gonna do NMR, but I'm just gonna stream that. I'll take the samples down and set them up and walk y'all through it so y'all will see how it's actually done. So thank y'all who streamed in. Thank you for streaming. And then you got questions, you can just email me. All right, y'all have a good afternoon.
Thank you. Have a good day.
Thank
Okay.
you.